Hello, Full Stack Fest. My name is Adam Smith. I'm Chief Technology Officer of Piccadilly Labs, which is a machine learning and AI company based here in Barcelona, and also Piccadilly Group, which is a software quality consultancy based in London. And I think the presentation is on the other screen, so if you'll just give me a second. Yeah. Great. So I'd like to start by telling you a story. In 2014, two people were arrested in America on the same day for very similar crimes. One of them was a young girl who'd just turned 18. So she found a bike lying on the street, a kid's bike, and she picked it up, and she started to steal it. And then she changed her mind, but it was too late. The police had already been called. On the same day, another person, a middle-aged man, he was arrested for armed robbery. And he used a weapon to go into a shop, and he stole power tools from that shop and held up the shop, if you like. So both of these people committed a crime of which the value was around $80 US. Both of these people went to court. They pled guilty to the crime. But they received starkly different sentences. And the reason for this is that in 9 states in the US, the judge receives a report. And they receive this report before they sentence someone. Now, this report gives a recommendation to judges on the likelihood of an individual offending again. We know 4 years later that the algorithm got this completely backwards in this case. And the algorithm recommended that she was sent to prison and that he was not. 4 years later, he's committed a series of violent offenses following that event. What's interesting about this is that there's no appeal. It's a case of computer says no. It can be very difficult to challenge reports and the output of algorithms when things are not transparent. Now, I'll go into this example a little bit more shortly, but first of all, I want to explain to you a little bit about why this is becoming an increasingly big issue. I want to give you some examples of the different types of ways this issue can manifest in software. I want to outline a few ideas for how you can evaluate your systems to see whether they contain any bias that you don't want them to. And the reason I'm doing this is because, as well as working at a couple of companies that look at AI and look at quality, I'm also a member of the IEEE's Ethical Design Standards Group, which is looking at a range of issues from autonomous cars to robots in healthcare to algorithmic bias. And personally, I think as software becomes more human, we as engineers have a duty to become aware of some of the ethical issues once we release something into the wild. So I'm going to start by talking a little bit about artificial intelligence. So a lot of people try and define AI. There's a lot of definitions of it. Some of those definitions are as simple as it's everything we haven't done yet. Some people believe it's about humans being perceived as human. But a lot of it really comes down to the research goals of AI. If you look at the Venn diagram I have on the screen, you can see some of the things that will resonate with you as areas that you read about a lot in the press. It's difficult to pick up a newspaper or a magazine without artificial intelligence being mentioned. So, the reason why artificial intelligence has gained traction over the past few years is not as simple as is made out in some of the articles. There hasn't been this massive breakthrough in research. In fact, the number of research papers written about artificial intelligence has been declining steadily since 2012. The factors that have driven us to become where we are now and to get onto this stage of the hype curve are, first of all, big data. So the variety of sources that data is consumed from, the volume of data that's being consumed. There's a statistic from early 2017 produced by IBM, which was that 90% of the data in the world was produced in the last 24 months. And that's only going to have increased in scale since then. But as many of you will know, that's not the only thing that's changed here. We have access to compute in a way we certainly did not 10 years ago. It's very easy to spin up a server, spin up 10 servers and process huge amounts of data in the AWS cloud or Azure. That compute also can come with GPU farms strapped on for specific types of modeling and specific types of work. It can come with pre-built knowledge. And also, the way developers are using it is often AI as a service. So you're connecting to web service that provides specific machine learning or other capabilities. And this means that the experts in some of these areas and some of these algorithms become further and further detached from the engineers and the end users with each piece of software. So what's really changed is our ability to gather and process data. So what isn't on this slide, though, is general intelligence. So artificial general intelligence. And that really means the ability for a machine to learn something in one context and transfer that knowledge to a completely different context. There's about 40 teams of researchers around the world working on this, but none of them will claim that they are close to anything being ready for any kind of production rollout. So what do we do when we can't implement general intelligence? When we can't solve any problem, we break it down into smaller problems. Looking at Prab's presentation just now, intents and the way you use intent classification in chatbots is the perfect example of this. When you talk to an Amazon Alexa, you get the perception that you're talking to something that has a level of general intelligence, whereas in fact, there's 1,000 separate intents, each of which has their own little AI. So by joining lots of narrow AI together, we create the illusion of intelligence. And by the way, for those of you that live here in Spain, Amazon Alexa may not be familiar to you, but there is a team in Poblenou working very hard at the moment on getting that working with the Spanish language and rolled out this year. So my overriding point here really is that we need to be careful about the information and power that we give to machines, and not to be fooled that they are more intelligent than they actually are. So just drilling down a little bit into machine learning. So machine learning is another thing that has significantly changed and enabled us to make the technological developments we have made in the last few years. And this is very different to coding, because the majority of the work is achieved by training a model with data, not by explicitly coding. So you analyze data, you extract features from that data, you rank them based on the importance that they have, and you train the model to behave as you wish. We're moving away from explicit programming and moving into a training mode. Another interesting thing about machine learning is it infers absent attributes, so data it doesn't have. It infers those within the algorithms. Ultimately, it's good at classifying things, grouping things, counting things. But just because it can learn doesn't mean it's self-aware. It's not the same as cognition. Machine learning can't be fair or just unless it's given fair and just data. A few other issues with machine learning, or not issues, but differences. The approach to it is development. You don't necessarily follow the workflow that you would follow when developing software against a hypothesis or against a requirement. You typically spend a long time playing around with data and trying to get it to output the right things without necessarily understanding exactly how it's working. It can be a black box. It can be very difficult to explain after the fact exactly how it's come to any particular conclusion. And the other thing that's different is that developers working with machine learning models have a tendency to use as much data as possible to try and get the model to output the result they want, rather than someone sitting down and deciding what data is actually relevant. So what's the problem that I'm really getting to here? So AI technology is moving forward really fast, but not at general intelligence level, not at transferring knowledge between contexts. We humans have a set of moral values, and those moral values can't currently be added to any kind of algorithm. There's research going on, but it's not possible right now. Machine learning algorithms find patterns, so we as humans do this as well. Rules of thumb, heuristics, common sense. These are imperfect methods where we consume data rapidly and make imperfect decisions. Now, this is all well and good, but where you combine this with the data that defines us, our personal data, and by that I really mean our identity, our political opinion, our sex life, our color, our gender, all of these things make up our identity. And when you use machine learning with this kind of data, there are some very significant and unique risks that can manifest. So, just talk a little bit about bias. So bias is a statistical concept. All machine learning is biased towards the data which it has observed, whether that's in training, in testing, maybe even in the production environment. The first relevant type of bias is selection bias, where the data that it's given is skewed, it's incomplete, it's not representative of what is the reality in production. An example of how this can occur is taking an algorithm that's been trained in one environment, maybe for the UK market, and trying to apply that to the Spanish market. Another type of bias is confirmation bias. So for me, I started my life as an independent tester, or I started my career as an independent tester, and this is something people are very aware of, is developers and testers, if you don't have some kind of separation, and at least the thought process is there, you can confirm things work without really proving that they do. One particular risk here is overfitting. So overfitting is where you tune the model so much to work on the data set that you've got in front of you that it works perfectly, but you expose it to different data and it all falls down. You essentially over-tune the model. Another type of bias is training bias, is when the bias in the engineer affects the model, when they believe it is right because they have brought bias to the equation themselves. But as I say, all machine learning is biased. This is a fact. What we're looking for is inappropriate bias, bias that has a negative impact on the stakeholders of the system. So, some level of bias is natural. Minorities are always going to be underrepresented in production data sets, for example. So great care is necessary in preparing the data and stripping out unwarranted bias. So let's take a look at some examples. So this is a computer vision system. When you upload your picture to apply for a passport in New Zealand, there's an algorithm run over your face. And this guy, the algorithm said his eyes were closed. It denied a passport. This is a perfect example of algorithms and machine learning being trained on one type of data, and then when they apply it to different sets of data, it comes to very different conclusions. So these examples can often be very newsworthy and typically affect minorities. That isn't an issue if the bias applies equally to different groups of people, but often that isn't the case, and that's when this stuff really hits the press. So let's take another example. So researchers used browser plugins to look at the different ads that were being served to different people, and they found that Google disproportionately would advertise higher paid jobs to men. Now, there's a counter-argument here, and there's counter-arguments throughout a lot of this presentation. There's a counter-argument here that women click on the higher paid jobs less, and the model had trained itself not to display those images to women, those adverts to women, because they didn't actually click on them. And this is interesting because the bias that actually exists in the real world is then being reflected within the machines. Another example in face recognition. Face recognition is notoriously unable to track darker faces as effectively. It's notoriously unable to recognize darker faces as effectively as it is able to recognize white faces. One of the interesting things here is there's work going on in China to make sure that there is enough freely available data using faces of Chinese people to train algorithms effectively, because at the moment it's heavily skewed towards the US and to Europe. So what's the solution to this? Is it more data? I mean, research has shown that if you quadruple the amount of data that you use to train an algorithm, you double the effectiveness of that algorithm. But one big risk here is people take data from the internet. So using data that you find on the internet to try and remove bias from your model is a terrible idea. This is typed CEO into Google Images. And whilst there's at least 1 or 2 women on there, it's skewed towards white men. It's been shown a lot that taking publicly available data disproportionately reinforces existing bias. And this is important because this is like money laundering for prejudice. You're taking bias that exists in society and you're packaging it up all nice and clean into an algorithm. And it may be years before anyone detects or corrects that bias. The University of Virginia found that using Google Images to train image recognition systems teaches it to associate women and kitchens. Similarly, an unsupervised learning system that used different people's names, so black-sounding names and white-sounding names in America, they found that it started to associate pleasant words with white-sounding names and unpleasant words with black-sounding names. That was at Princeton University, incidentally. So it should be clear now how data can influence systems and introduce bias. However, there's a further complexity to this problem. So I'm just going to switch to, this is a screenshot from my Twitter profile. So Twitter has decided that I'm male without me actually telling it that. That's great. It got that one right. It's also decided I'm not under 13, and I'm not between 55 and 65. But how does it know this? It's looking at different things I do, and it's making assumptions. And that can lead to a kind of indirect discrimination, in fact. Because once data items become inferred from other data items, as an engineer, you start to lose control of what you're actually dealing with. Things like your location, your postcode, your zip code, that encodes a huge amount of information about you. Your political opinion, your ethnicity, your socioeconomic class can be guessed from your zip code. Your shoe size, for example, can tell people a lot about you. So let's take a look at some of the examples where this has happened in the real world. So Staples, if you don't know Staples, they're a huge stationery retailer in the UK and the US. Now they made a decision to reduce the prices on their website for people who lived near competitor stores. Seems like a completely logical decision. But what this led to was consistently higher prices for people in lower income groups, which seems less appealing to Staples. So they quickly changed their system and put the prices back. But there's a rational reason why they did that, and it's not necessarily unjustified. Amazon as well. So Amazon were found by Bloomberg to be offering differentials. They're excluding services, in fact, excluding people from services in predominantly black areas. Amazon doesn't know your race, but it's extrapolating it from your zip code. There's a counter-argument again. There's a counter-argument that they're a delivery company. Of course they can decide which zip codes they deliver to. Maybe there's some safety issues there that are also packed into this issue. But for us as engineers, what's important is it wasn't what Amazon wanted at all. They did not like this press attention. So let's go back to a scarier example, which is the one I started with. Oh, hang on, Facebook. So Facebook have patented figuring out your socioeconomic group from things that you click on Facebook. Now, Facebook gets a lot of flack for things they've done. This is one of, I think, the more worrisome ones. Do you really want advertisers to be able to pick your socioeconomic group and pick whether they want to show you something? So going back to the example I started with, Compass. So this was revealed in an investigation by ProPublica, who did a lot of the work recently on revealing what's going on in some of the refugee camps in America. So Compass predicts reoffending risk and is an input to sentencing. It uses 137 different data inputs, things that criminologists look at, like whether you're a drug user, single parent, things like that. And it makes predictions about you. And what's been found is that you are 77% more likely to be predicted to commit a violent offense if you are black. So going back to that story at the start, the young girl, she was black, the middle-aged guy, he was white. And you can see clearly up here that there's a relatively normal distribution for the risk scores of black defendants. But on the white defendants, the one which is the lower risk is disproportionately allocated. Now, where this is a proprietary algorithm. This is not accessible to the general public. There's been numerous legal challenges to this specific system. There's also been attempts to try and remove some of this bias by mathematically injecting different types of bias, which actually ended up having unintended consequences on other types of people. There's a whole level of complexity here in trying to get systems to behave using values that we think are acceptable. But where this is really risky is where there's no error feedback. If people can't appeal to a human, if they go to prison, they can't prove that they weren't going to violently reoffend because they're in prison. So let's take a look at some other risk areas. So this is actually I nicked this from the French data protection officer and added in evolved it a little bit. These are some of the areas where people are getting a little bit concerned about how algorithms can be used. Now, 2 of these areas have happened over the past 2-3 months in the UK. Predictive policing is being rolled out in the UK, predicting who will commit crimes. We have a case in the UK where university admissions nationally are passed through a fraud detection algorithm. So you apply for university, the form gets uploaded, there's an algorithm that says this is a fraudulent application. And you're 5 times more likely to be deemed to be a fraudulent applicant if you are black. There was at a festival in the UK over the summer, lots of people going out enjoying themselves. They hooked up face recognition to a laptop and started scanning, hooked up facial recognition to a laptop and started scanning the crowd looking for people on their database of fugitives. They found 100 people, of which 6 or 7 were actually fugitives. So 94 people were incorrectly identified as fugitives. They were stopped, they were searched, they were subject to interrogation. So these are real use cases where there is a high risk because data about people's identities is being combined with algorithms that we don't necessarily understand or sufficiently regulate. So what's the answer? Is it more regulation? I don't think it is. I mean, in Europe, we have some pretty good human rights legislation that already stops us from discriminating against people because of their identity and their protected characteristics. We also have GDPR, which people have different views on, but it does include the right not to be subject to an algorithmic decision where it has a legal or vital effect on you. So if it could affect your life or your freedom or your legal status, you have a right to appeal against any algorithm. So, we've got enough legislation, but let's recap. Machine learning is a key part of AI. Its use is significantly increasing. Wherever personal data is processed, there is a risk of unfair bias. Protected features like race, gender, political opinion don't need to be in the inputs. You're not just looking at the input-output domain of the algorithm. There are other things that can come into play. And bias can emerge not only when data sets don't reflect society, but also when the data sets do accurately reflect society, but they reflect an unfair aspect of society that you, your company, don't want to replicate. This bias can certainly be unlawful, especially within the EU. So, how can you determine whether something that you have built, an algorithm that you have built, is discriminatory against people that belong to specific subgroups? And the first one is easy. You can take the inputs to an algorithm, and you can tweak some of the inputs, change the race, change the date of birth, change the shoe size. That's simple and easy to achieve, but it is done on a very small scale. The next thing you can do is obviously group inputs. You can take a whole set of inputs that belong to people of a specific subgroup, run them through the algorithm, then run a different subgroup through, and then compare the results. And that gives you a wider picture, but it doesn't detect where external data and latent variables are affecting the outcome. So the most effective way this can be done, and this is exactly what happened with the Staples example and the Amazon example that I gave earlier, is use external data sources, for instance, a census. So a census being where the government gathers every 10 years a list of everyone that lives in a zip code and all their different characteristics. So you can bring that data into your evaluation process and start to determine whether there is any kind of latent variable affecting the outcome. I'm not sure how you could approach this with shoe sizes, though. So a few thoughts here about how you can approach, throughout the life cycle, this kind of problem and make sure that you bake your values into the algorithmic system you're designing. The first step is identify who your stakeholders are. Who are the people that matter? Who are the people that are going to be deciding what is warranted? Who are the people that are going to be affected? How is society a stakeholder from your algorithm? You need to consider the risk and impact. 90% of the algorithms we build hold very little risk and have very little impact on people. But we've all seen how things like political advertising can be misused. Think about the diversity in your team. If there's 4 white young guys in a shared building, some kind of startup, then maybe they're not going to have the perspectives that a wider team would have. Maybe you should be using production data. A lot of people are very against using production data to evaluate your code, but this is one example where the bigger the data source, the more effective your evaluations will be. Maybe you should determine some acceptance criteria. What's acceptable bias for you? The test techniques I showed on the previous slide, what's appropriate for the level of risk that you have? What sort of tools do you need to build? Because this sure isn't manual testing. What consents and notifications do you need to give users? If you're profiling people based on their personal data, you have to tell them it's the law. It's in GDPR. And then, lastly, once you go live, once you take an algorithm live, you need to constantly reevaluate it. It's constantly getting new data, constantly having new experiences and changing. As I said earlier, if you're applying things to different markets that they haven't been trained in, you need to consider that as well. And of course, you need to monitor whether the social norms have changed. People have a different, this year there's been the Me Too campaign, for example. People's attitudes about certain things change on an annual basis. And you need to continually monitor that kind of thing. So, why am I here talking about this? As I said at the start, I'm working with the IEEE on a whole bunch of ethical standards for technology. I'm really interested in use cases that people have, problems people have had in this area, concerns people have, and ideas people have about how to reduce the risk of algorithmic bias within the systems that we develop and how they affect technology. So I think I'm just about on time. So thank you for your time, and I'll take any questions.
It's great that you are so involved in this kind of stuff. How does all these considerations affect your everyday life at job, and do you have like profitability issues? Does being attentive to these things really slow your business, or how does it affect it?
It's a good question, and that's why we originally started looking at this, because we were looking at how we, in fact, allocate work to different engineers. So how we allocate the most effective work to the best engineer to complete a task. And we took a step back and we thought, well, isn't there some issues we need to think about here? There's some ethical issues. And that's when we started looking into this. And since we started talking about this publicly, we've had quite a number of companies, big companies in the UK, come to us and want to meet to talk about assistance for developing their own data ethics policy. I think data in 2018, the ethics around it has suddenly become a much bigger issue. And we're starting to see it becoming a real revenue stream from people that want to invest in this area to make sure that their reputations aren't damaged in the way that some of the companies I just flashed up on the screen have been.
Yeah. So it's basically the market that asks for actually doing things the complex way, the complete way, not just the easy way. And yeah. And do you think that we will find one day the right way to do it, or will it just be all the time readjusting and readjusting? And how do
I
you
think
see
as
it?
technology develops, we need to keep our eye on the ball. We need to be constantly assessing our practices. And at the moment, to be honest, we're a long way from having a set of tools and techniques that engineers can pick up. There isn't a book about this out there. This is kind of new stuff, and it's evolving every single week, every single month during this year in particular.
So you kind of need to be, in some way, like a sociologist as well, as well as a developer and a tech guy.
Yes. So some of these working groups, they have psychologists, politicians, machine learning experts from around the world. There's a real focus about cross-disciplinary examination of how we develop software now.
Very interesting.
Thank you.
Thank you too.